Hello everyone, here is the next question. Balanced binary tree. So let's read the question. Given a binary tree, determine if it is height balanced. So let's see what is the definition of height balanced. A height balanced binary tree is a binary tree in which the depth of two subtrees of every node never differs by more than one. So let me write it the condition here so you can understand clearly. ABS of left GIGST height minus right height, it should be less than or equal to 1. Okay, so what is ABS? ABS is a in C++, it is a inbuilt function which it takes a number, it takes a any number like positive, negative or 0, and it will gives me a positive number. Like if I'll pass a negative number, then it convert into positive number. Like if I pass 0, it will return 0. For a positive number, it will return as it is. Like I'll pass minus 3, then it will convert minus 3 to 3, positive 3. So it will return positive 3. So the absolute difference of the left height tree and the right height tree should be less than or equal to 1. If it is not, follow this condition. If any node is not following this condition, then it is not a balanced binary tree. Okay, so let's see for example 1 and calculate, check for every node and see if it is satisfying the condition or not. So let's try to do that for node for node 3, which is this. Calculate its left height. ABS of left height, what is the left height, is 1 minus what is the right height, it is 2. So this will be 1 minus 2 is minus 1, and what ABS will do is convert minus 1 to positive, so it will be 1. So this is satisfying the condition which is less than or equal to 1. Okay, now we will check for node 9, which is this, and calculate its left height. What will be the left height? It will be 0. There is no height, and its right is also 0, so it will be 0, and 0 minus 0 is 0, and ABS of 0 will be 0. So this is also satisfying the condition which is less than or equal to 1. Now we will check for a node 20. It will be ABS of what is the left height, it is 1, and what is the right height, it is also 1. So 1 minus 1 is 0, and ABS of 0 will be 0. So this is also satisfying the condition which is less than or equal to 1. And if you check for this 15 and 17, this is also satisfying the condition. So all the node in this tree is satisfying the given condition. So we will return true. Now let's analyze for the test case 2, which is given here. So let's analyze for the root 1, root which is node 1. What is the height of left tree, left subtree? It will be 1, 2 and 3 minus what is the right height? It will be 1, and 3 minus 1 will be 2, and ABS of 2 is 2. So you can see this is not satisfying the condition which is not less than or equal to 1. So here you can directly return false, because for the binary tree, if it is height balanced, then it for every node this condition should be satisfied, and for the root node itself it is not satisfying this condition, so we will return here false. No need to check further its node, directly you can return false. Now solving this test case or analyzing this test case, one possible solution is that go for every node and calculate its left height of subtree, and right height, and then check for the condition. If it is satisfied, then further go to its another node and go for another node. Otherwise, if you get a node which is not satisfying the condition, you can directly return the false. So the time complexity for this will be big O of n square, y n square, where n is the number of nodes in a binary tree, y n square because you are calculating, you are visiting node every twice every time, because you are calculating for height, once you visit for a height and once you visit for the condition. Like you are at the 3, you calculate its left height 3, then you will visit 9, and then you will go 9 for 9 for this node itself. You check for the condition left height and the right height, then see for the satisfying condition or not. Okay, uh, we can do better. Let's see how. Okay, we are calculating separately for its left height and the right height. Why we not calculate simultaneously? Let's see how. Let me store get height, height of the tree. It will be integer, height of tree. So get height, it will be root. Okay, so an integer, it is going to return integer get height tree node root. So let's see. So we will calculate. We are on the root. Let me calculate its left subtree, left height. Sorry, it will be left height get height of root ka left. Okay, so I am assuming this get height function gives me left height. Okay, I am assuming integer right height equal to get height root ka right. So again I am assuming this function gives me a right height. So what can I do with these two uh, value? Left, I'll get a left height and the right height. So you are assuming that you are, let's say you are, I am assuming that I am on the node 20 and I'll get its left height and its right height. What is I'm getting its left height and its right height. What can I do? I'll just check for its condition. ABS, if ABS of left height minus right height should be less than or equal to 1. Okay, if it is not satisfying this condition, if it is false, then I'm going to return, this is I'm checking condition. If it is okay, if this condition gives me a false, then I'll return not false, we will return -1 because we are returning integer. Let's see how. So I am on this node 20 and I'll get its left height and I'll get its right height. I'll compare. For now this is satisfying, left height and right height is satisfying for the 20. Then what I will do, for also I'll pass the height of this till now. So what can I do? Return maximum of left height minus right height and +1 for the root itself. I am returning the -1 only. So whenever I'll get a height is 0, 1, 2, 3. So it is positive, not a negative. The height of any tree, it will be positive, not a negative. So I'll passing a negative value, which is saying that negative value indicate that it is not a one. I'm getting a one root which is not satisfying the condition. So I'll check for left height. If left height is equal to -1, then I'll return -1. No need to go further. If right height right height T, okay, right height equal to minus 1, then return minus 1. So I'm returning the height of the tree every time, and whenever I'll get a node which is not satisfying the condition, I'll return minus 1. And if my left height is getting minus 1, which means there is some node which is not satisfying the condition, so I'll return directly minus 1. If I'll get a right height minus 1 indicates that there is a node present which is not satisfying the condition. After that, I'll write a base case. What is the base case? If root equal to null, then what is the height of the null value is 0. So I'll return 0. At last, if I'll getting a height of the tree, if I'll getting a height of tree is positive, that means uh, this is a height balanced. If I'll get a height of tree is minus 1, then I'll return false. It is not a balanced binary tree. So I'll check if if 1 second, height of tree equal to minus 1, then I'll return false, otherwise return true. So that's it. Let's try to run and see if it is working. Okay, I am getting an error. No matching function call max. Okay, so I have to take a maximum of left height and right height. Now let me run this. Okay, another an error. Okay, height of tree, undeclared identifier height of tree. Okay, it should be HEIGHT. Now it's work, I think. Not work. Here it is also. Let me copy this, paste it over here. Okay, accepted. Let me submit this. So the time complexity of this solution will be big O of n because we are visiting every node at once. So where n is the number of nodes in binary tree, and there is also a recursive stack space which is big O of h, where h is the height of binary tree. So that's it. Thank you.